All right, here we go. Same topic. We're looking at indefinite integration. But now we're going to be looking at some things with trig. We're going to do part 2 here with trig. So first we got this table, and keep in mind that the left side of this table you guys have done quite a bit with. You've looked at the derivative of sine is cosine, cosine's negative sine, derivative tangent secant squared, cosecant squared, all that kind of stuff. But now what we have to do is start thinking of those shortcuts in reverse order. So when we say the derivative of sine is cosine, then the antiderivative of cosine is sine. Now, something that we want to keep in mind here, we can balance these equations with negatives if we need to. So for example, the antiderivative of negative sine is positive cosine, etc. So, all that we really need to watch for is the plus or minus kind of change. But in general, it's going to feel very similar to what you've done with derivatives with trig before. Here's a table within your packet too that will help you kind of follow through just the order of watching those positives and negatives, especially with sine and cosine. But it just kind of comes with practice. So let's practice. All right, I see a function here. It's got a constant out front and then sine of x. So what I'm trying to think of is the derivative of what equals sine of x. That's the question that we're trying to answer. Well, we know the derivative of cosine is negative sine, so this must be the derivative of negative cosine then is sine. So the antiderivative of sine is cosine with a negative. Plus c, so it's going to be negative 4 cosine x plus c. This next one, I see two constants here, one in the numerator, one in the denominator. I can put those into one combined fraction, negative 2/3. Then we have to think about the antiderivative of cosine. The derivative of sine is cosine, so the antiderivative of cosine is sine. It's that easy, sine of x. All right. Okay, now we're going into this next one. And I know a lot of times when we see a term in the denominator, or a piece of the term in the denominator, we want it to be up in the numerator. That's helpful for power rule because we like powers in the numerator. That's just what's easier for us to do. But in this case, we want to think of cosine as in the denominator as 1 over cosine is going to be a different type of relationship, and we call that secant. The reciprocal of cosine would be secant. So this is really the antiderivative, or the integral, of 5 secant squared x dx. So we treat the constant like you would think. It's just factored out, and then it's there. It's left over. And then we got to think of secant squared. What's the antiderivative of secant squared? Well, the derivative of tangent is secant squared. So the antiderivative of secant squared is tangent plus c. I forgot the plus c over here. You guys are probably screaming at the screen. Alright, now let's combine some ideas that we talked about before as far as like constants. We got adding, subtracting, more constants. Let's start with the first one. So we have 4 times the antiderivative of cosine x, and then we're going to have minus 9 times the antiderivative of sine x. Well, the derivative of sine is cosine, so the antiderivative of cosine is sine. That one's pretty straightforward. The derivative of cosine is negative sine, so we're missing a negative in here, so that means that it should have been negative cosine. Now, of course, you could have done that or taken this negative here and used that as your negative, and right now we're going to see how it all balances because now these two negatives make a positive. But in general, that's what we would have done there. So 4 sine x plus 9 cosine x plus c. All right. There's a lot of temptations with this one. We see this and we want to say, okay, how do we deal with the negative sign? And then you want to deal with the cosine separate. But in fact, we got to do a little bit of simplifying and combining with those into different terms, kind of like what we did up here in number 22, where we changed the label of it. So I'm looking at this, and I don't see sine over cosine squared. I see sine of x over 2 cosine x's, like this. This is what I see. And even more so, we need the dx here, even more so, that means I can split this up into -1 over cosine times sine over cosine Let's keep going with this. We know that 1 over cosine is secant, so that means this is negative secant x. Over here we have tangent x. We haven't done any calculus at this point. We've only done some pre-calculus simplifying with trig. I see this negative out front, and I don't really need it because secant x tangent x does have an antiderivative. In other words, there's something that when you take the derivative, you get secant x tangent. That is secant. But this negative is a constant. It's -1, so we're going to carry that through. So it's secant x with a negative, and then plus c. Now number 25. 25 is an interesting piece here. A lot of people freak out because they're not used to theta as a variable. So let's calm them down. Let's change that variable, but keep it consistent throughout the same way it's written up here. Let's call it, how about t? So t squared minus 2 cosecant squared, whoops, we want a t, all this times dt. That doesn't look so bad. We've done stuff like that before. In fact, now we got some older traditional power rule and some trig at the same time. So let's deal with each one separate since they're adding or subtracting. So the antiderivative of t squared becomes t cubed over 3. We got this -2 as a constant that we're going to pull out to the front. Then we got to find the antiderivative of cosecant squared. Well, I know that the derivative of cotangent is negative cosecant squared. So if I were to do the antiderivative, that means I need, but this is positive. So I'm going backwards, so that means the negative needs to be over here. That means this should have been negative cotangent of t. We're using t this time. And of course, plus c. Alright, let's see. Do we got any more of this trig? I think we got maybe one more in here. We got empty page. Oh, no, now we're into differential equations. So, pause, then play part 3. See you then.